welcome to a Math Warehouse video on SAT prep involving triangles. This question will involve a right triangle and the Pythagorean theorem, so let's take a few moments to review that formula. Most people are familiar with a squared plus b squared is c squared with that formula, and that's the Pythagorean theorem, which relates the three sides of a right triangle, and c, of course, has to be the hypotenuse. The animation on the top attempts to show what the formula means, that the square of c is the same area as the square of a plus the square of b. But enough of that, let's just get to the brass tacks and the question. Let's look at the question. A right triangle has legs with lengths of 15 centimeters and 36 centimeters. If the length of this triangle's hypotenuse in centimeters can be written in the form 3 square root of d, where d is an integer, what is the value of d? Again, I took a practice question on one of the official College Board practice tests, and I just changed the numbers. So this is a very authentic style question. And we're just going to plug in 15 and 36, the legs for a and b, and 3 square root of d into c for a squared plus b squared is c squared, right? Here's a diagram of it. And in the formula, we have 15 squared plus 36 squared equals 3 root d squared. So we simplify the left side, you're going to get 1,521 equals 3 times the square root of d squared. So the next step is I'm going to take the square root of both sides. When I take the square root of the right side, it's just going to become 3 times the square root of d, and the left side will of course become the square root of 1521. And we're trying to find d, so I can now divide both sides by 3 to get rid of the 3 on the right, and to get the square root of d is 13, right? Then you just take the square of both sides. Square the right side, the square of the square root of d is d, and 13 squared is 169, and of course that's the answer, 169. It's a very straightforward question. This is not the first. The only trick is dealing with the 3 square root of d.